Okay, let's dive into this. Welcome to today's Explainer, where we're going to totally crack open the essential mathematical toolbox you absolutely need to survive and honestly thrive in 11th and 12th grade physics. So if you've just started your physics journey, you've probably already realized that math and physics, yeah, they're completely inseparable. It's like a giant puzzle. But hey, don't worry, because we're going to make this incredibly straightforward and actually kind of fun by looking exclusively at the practical tools you need.
Here's our roadmap for today. We're going to cover the math tools for physics, the meaning of differentiation, some basic math rules, the product and quotient rules, and then we'll wrap the whole shebang up with some homework and next steps. And let me just reassure you right off the bat, even if you didn't choose math as a core subject, you can absolutely conquer physics by mastering this exact structured roadmap we're looking at today.
All right, Section 1, Math Tools for Physics. And remember, we shouldn't view this as some dry, theoretical math class, but really, it's just about acquiring a totally practical toolbox.
So these three branches, differentiation, integration, and vectors, they're the primary math tools that are going to pop up throughout your entire physics syllabus. If you understand these three, you literally hold the keys to the kingdom. But today, we're exclusively focusing on the very first one on that list, differentiation, which is also commonly referred to as taking derivatives. Moving right along to Section 2, the meaning of differentiation. And just to manage expectations here, since this is a physics explainer, we absolutely won't be doing any deep, complicated mathematical proofs. We're just going over exactly what we need for physics.
Differentiation is calculating small changes in a quantity with respect to another quantity. That's the formal definition. So the crucial point is that differentiation is really just a tool for measuring how one thing shifts when another thing changes. It's all about capturing those tiny, minor fluctuations.
So what does this actually mean in the real world? Well, in physics, when changes are extremely small, we use differentiation. Think about finding velocity. You're just looking at the tiny change in displacement, which we call x, with respect to time, t. So velocity is simply dx over dt. Similarly, acceleration is just the tiny change in velocity over time, giving us dv over dt. Honestly, whenever you see that little lowercase d, just train your brain to think a tiny change in.
Okay, Section 3, the basic mathematical rules. We are now officially opening our toolbox to look at the most frequent foundational rules that you're going to use in, well, almost every single physics chapter from here on out.
Let's start with the absolute superstar, the power rule. It goes like this: d over dx of x to the power of n equals n times x to the power of n minus 1. The rule is wonderfully simple. The power just comes forward, and then the power is reduced by 1. So, say you want to differentiate x to the power of 5. That 5 simply comes down to the front, and the power drops by 1, giving you 5x to the power of 4. And hey, even if the power is a negative number, the exact same logic applies. Next up is the constant rule, which states that the differentiation of any constant value is always 0. The logic behind this is actually beautiful. Remember, differentiation measures change, right? Well, a constant, like the number 3 or 101 or even negative 131, it never changes. It is completely static. So logically, its change, its derivative, is exactly 0.
And this brilliantly illustrates where a lot of students actually get kind of confused. Let's compare two different concepts. First, we have sine of 60 degrees. Since sine 60 is a strict constant value, it evaluates to the square root of 3 over 2, and it's always going to be that, its derivative is absolutely 0. But look at sine of x. X is a changing trigonometric variable. Because it can change, its derivative is not 0. It actually transforms into cosine of x. You always have to ask yourself, is this a strict value or is it a variable?
Now, moving on to the constant multiple rule. This just shows that if a constant, let's call it c, is multiplying a variable, you simply pull that constant safely outside the differentiation process. You just park it on the side for a minute. Then you apply the standard power rule to the variable and just multiply the constant back in at the end. For example, if you have 3 times x squared, you pull the 3 out, differentiate x squared to get 2x, and then multiply them to get 6x. Super easy. Then we have the sum and difference rule. It says to treat multiple terms separated by a plus or a minus individually. So if you're staring at a really long equation with multiple terms added or subtracted together, don't panic. You just calmly differentiate each piece one at a time, keeping the plus or minus signs exactly where they are.
I highly recommend you take a mental snapshot of this cheat sheet right now. We've got the power rule, the constant rule, the multiple rule, and the sum or difference rule. Seriously, lock these in because these rules are your primary survival tools for 11th and 12th grade physics.
All right, Section 4, Product and Quotient Rules. Now we're shifting our focus to some slightly more advanced tools that will definitely pop up in later chapters when two terms are either multiplying or dividing each other. Let's move to and see how this builds when two variables are actually multiplying each other. You can't just multiply their individual derivatives together, no way. Instead, you use the product rule and follow this rhythm. Step 1, differentiate the first term, but keep the second term exactly the same. Step 2, add a plus sign. Step 3, do the reverse. Differentiate the second term and keep the first term exactly the same. See, it's a beautifully balanced process. Now let's tackle the quotient, or division rule, which we use when terms are dividing. It feels kind of similar, but with some absolutely critical differences. Step 1, differentiate the top numerator, keep the bottom denominator the same. Step 2, and this is crucial, we subtract. Use a minus sign, not a plus. Step 3, differentiate the denominator, keep the numerator the same. And finally, Step 4, you must divide that entire result by the original denominator squared. It requires a bit of focus for sure, but once you memorize this flow, you'll nail it every time.
And that brings us to Section 5, Homework and Next Steps. This is the final segment of our explainer today, and honestly, I am so excited for you to actually test out your brand new physics toolbox.
All right, you've seen the concepts, you've got the rules down. Now, I am vigorously challenging you to solve these 5 homework problems. We've got a great mix here, some power rules, a product rule in question 1, and a quotient rule in question 5. I want you to work these out and drop your answers down in the comments, and do it with absolute honesty. In fact, I want you to type the phrase Amandare OP, meaning absolute honesty, along with your answers so we know you put in the real work. So now that you have these basic mathematical tools securely in your toolkit, ask yourself, are you ready to conquer the universe of physics? Starting with your very first real chapter, Units and Measurements, you are now fully equipped for the journey ahead. You know how to measure change, which means you are literally ready to measure the universe itself. Thanks so much for joining me on this explainer, and I will see you in the comments.